So, hello everybody. My name is Bruno Siciliano. I am a professor of control and robotics in the Department of Electrical Engineering and Information Technology at the University of Napoli in Italy. Actually, it's the University of Napoli Federico II, who was the founder of the university back in 1224. I am director of the Prisma Lab. Prisma is an acronym that stands for Projects of Robotics for Industry, Services, Mechatronics, and Automation. And today, I'm going to speak about one research areas in which we've been working in the last 6-7 years, and this is the area of aerial manipulation. So to give an idea of what kind of research we've been engaged in the last 30 years, I have just one slide introducing my Prisma team. This is my team. They knew that I was with you here this morning, so they are just cheering to all the readership of the International Journal of Advanced Robotic Systems. So besides myself, there is Luigi Villani, who is an associate professor, and Vincenzo Lipiello, who is an assistant professor, and all the other names are either postdocs or PhD students in our team. And as you can see from this slide, we've been engaged in a number of projects, research projects, which have been funded by the European Union. Those are the 3 projects which were funded in the 6th framework program, and those are the projects which have been funded in the 7th framework program. And actually today I'm going to speak about these 3 projects in the middle column, which concern with the area of aerial manipulation. So I'll be speaking about the iRobots project, the ARCA Project, and the Sherpa Project. And also in the last column, maybe in the next lecture to celebrate the 15th anniversary of the journal, I may be speaking about the new project, which is Rodiman, and it's about robotic dynamic manipulation. But this is maybe in another opportunity. We've been lucky, or maybe we've been good, to raise a pretty nice amount of money for funding, because we got 8.3 million euro financial support in the last 5 years, thanks to all these projects. So, as an introduction, being a professor, I'm always used to give definition, and it's good to classify what we mean by aerial manipulation. We mean the grasping, transporting, positioning, and either assembly or disassembly of mechanical parts, measurement instruments, objects. And the peculiarity is this kind of manipulation is not carried out by a ground-based robot, a fixed robot manipulator. It's not carried out by a mobile manipulator on wheels or maybe on like a crawler, but it's carried out by a flying manipulator. So this is the specifics of the system which are known in the literature, in the technical field, as unmanned aerial vehicles. And the peculiarity is that they allow a vertical takeoff and landing. So this is the case, for instance, of a helicopter compared to the typical fixed-wing vehicles that need a sort of launching pad or like a sort of landing platform. So UAS, unmanned aerial systems, were around since 15-20 years. Why it's now of interest for the field of aerial robotics? Because these systems not only inspect, surveil, so it's not only to have a sort of flying eye. For instance, this is being filmed, and now in the media industry, you can use drones, you can use flying cameras to inspect. The peculiarity here is to have not only a flying eye, but also a flying hand. So the possibility of having a hand that flies, and in such way, if this system is endowed with the gripper or a robotic arm, not only can I inspect, but also I can do some sort of manipulation. And this is what I'm going to illustrate in the next slides. But so these are just a number of applications which, one way or the other, are at the frontier of service robotics. So this is the use of quadcopters for aerial rescue in alpine, in mountain environments. This is a sort of funny application in which the drone is a sort of patrolling a biker, in the sense that you can set up the speed and you can have the biker to adjust to the speed, and also you can do filming of your performance. And this is another rescue scenario in which there is a fire and there are some kind of people to be rescued, and you can use drones to rapidly localize the people in need of rescue. And this is also some sort of a visionary scenario in which multicopters are being used. And let me illustrate some applications which are very tough to be solved by humans. And what you will see in these videos are a number of interventions where the labor, where the human operation is at risk. So those are hostile environments in which it might be very dangerous for a human to carry out this task. So this is the case, for instance, of this bridge, and you can see that the operator is kind of suspended at a very high height and has to carry out the application, and there is a danger and there is a risk of an accident in this case. The next application is also similar. Can you probably see those people walking along the bridge? Of course, they have strings for safety, but again, I think you agree with me that this is a very awkward operation to be carried out by a human. And there's another similar application here in which, again, there's a sort of human intervention. So the difficulty here is posed by the hard access to the place where you have to do the maintenance, the repair, or the servicing, and also the fact that you might have winds, you might have currents, and those are kind of disturbance for the human operator, and likewise will be for the robot whenever those will be used. And in the last video segment, I will show one application of servicing for electrical power plants. So you can see that the operator is transported by a helicopter. Then it gets to the same voltage, not to get killed, and the operator does the repair manually, and it's kind of suspended. So we don't want this operation to be carried out by humans, because the operations are very expensive and they also expose the human to risk of injury or even death. As a first contribution in research, we worked to solve this kind of problem. But before I address the research issues, let's see if aerial manipulation might represent a sort of business opportunity. This is a movie. You can recognize Amazon is a provider for delivery of books and any kind of object. And you probably know the story of Amazon purchasing Kiva Systems. Kiva Systems was a company which was funded by my colleague at ETH in Zurich, Raffaello D'Andrea, and this was a smart idea of the mobile AGVs. So it's kind of optimizing the shelves for all the storage. And this is the same idea in which you are the third dimension. So it's kind of a flying delivery. And this drone can deliver the package to the consignee, to the recipient of the package. And so by the time you press the button, I mean, one day, in 1.5 days, you can have a kind of drone flying and delivering the package to the customer. So of course, there are a number of issues that have to be solved. The regulations are not clear yet in the field, but we are not too far from this kind of prospective application. A month ago, I was with my kids sitting in the room watching TV, and there was a nice commercial. And this is a commercial about drones. Actually, the image is not so positive because you see that some of the drones, they go hitting like posts. But this was a way also to market, in this case, an automobile, a car, and you see a platoon of drones. So this could be an additional business opportunity to use drones, in this case, for marketing. And it's kind of cool, it's kind of, in fact, my kids, they told me like, Dad, look, this is the kind of stuff that you're doing. So why don't you make money and doing commercial with them? Yeah, that's maybe another business opportunity. Just more serious, like we have a number of industrial applications. And so this is a huge plant. And you can see that the operator can operate in a more relaxed condition without having to jump, to crawl, close to the plant. And so basically he can operate the drones, he can teleoperate the drone, the drone in this case, and the drone can not only inspect whether any kind of, if there's, for instance, a pipe or a wall with some rust that has to be removed, but can actually operate an arm which is attached to the drone that is used to do this kind of manual operation. So let me come now in the second part of my video lecture about some research in aerial manipulation. As I mentioned in my introductory slide, we've been engaged into 3 research projects sponsored by the European Commission. The first one being the so-called iRobots project, which was a project that ran from 2010 until 2013. So this is finished. And as I somewhat anticipated, the novelty here is not only to navigate in environment. Here in these videos, you see as a typical SLAM problem in which you want to navigate the drone into some environment, and this is the typical simultaneous localization and mapping problem which is solved. But if I just go back here, you see here that there is a ducted fan, which is a type of aerial vehicle which is used, and here, I hope if I just can go back, just the video will be showing, there is a little arm which is mounted. This is actually a parallel manipulator which is mounted onto the ducted fan, and this performs some sort of task. In this case, was doing some kind of operation on the wall. And it was interesting to see that the kind of techniques, I'm a control engineer, and so we used some of the well-known impedance control techniques also in the context of aerial manipulation. The second project I'm going to speak about is the same concept of a flying manipulator, but this time there is not only one flying hand, but there are 2 flying hands. This is the so-called ARCA project. ARCA stands for Aerial Robot Cooperative and Assembly Systems. And in this rendering, you see 2 autonomous helicopters carrying a lightweight arm. This is a rendering of the KUKA lightweight arm. And the idea is to pick up this pipe and to carry in a very hostile location to access and to mount this pipe onto a sort of truss structure. So you can even do construction with autonomous helicopter. Of course, this is different from a small drone because this is really a big helicopter. But what I want to stress is that this operation can be performed either in a sort of teleoperated fashion or in a sort of semi-autonomous fashion. So this is the kind of problem that we solved. And since we are half the way, the 4 years of duration of this project, this is the first worldwide flight experiment of aerial manipulation with a fully actuated robot arm using force and visual control. So compared to the rendering, this is only 1 helicopter and 1 arm. But now we're working on the extension to 2 helicopters and 2 arms. So this is the flying field available at DLR. DLR is the German Aerospace Agency, which is a partner in this project. And you can see this helicopter carrying the same arm that you saw in the rendering. And we will perform this sort of aerial manipulation using visual control in the gross motion and then using force control in the fine motion. So basically, it's one scenario in which we can do the same task that we were doing with ground-based manipulators, but the difficulty is to do this with the flying manipulator. And as you can understand, the difficulty is that you have to compensate also for the current, for the winds which are disturbing, so your control algorithm has to be quite robust. That one was an outdoors application. This one instead is an indoors application. This is the flying arena available at CATEC. CATEC is the aerospace facility of which was sponsored by the Andalusia government, because the coordinator of the ARCA project is Professor Aníbal Ollero from University of Seville in Spain. And this is the flying arena there, and you can see a number of tasks in which we're using a quadcopter to pick up this bar onto which is available here, and also we use eye in hand, some visual surveying technique in which the camera is mounted on the quadcopter, and it's observing, is recognizing the object, and then it will duly pick it up and carry out in a satisfactory way. Typically, when you have a flying arena, you also have a motion capture system that is not used to actually control the quadcopter, but it's only used to check the performance. So this is the so-called ground truth. You want to estimate how accurate is your control and how well the control is performing. So we also have a flying arena at University of Naples, and we are performing this kind of experiment. The last project I'm going to speak about is the so-called Sherpa Project. And Sherpa is using a sort of hybrid technology, aerial hybridly combined with ground robotics to rescue people up on the mountains. And actually one of the partners in the Sherpa project is Club Alpino Italiano, which is the mountain association in Italy for the Sherpa. Sherpa is the name for the mountain guide in the Himalaya mountains. So as you have seen a scenario of, for instance, of rescuing someone who has been submerged by an avalanche. The life under an avalanche to survival is about 30 minutes, 45 minutes. So you need a rapid intervention. And sometimes the sensor technology is not enough. You can quickly localize the victim in need of rescue, but also you need some sort of technology which assists you, and in this case assists the Sherpa guide to help and possibly save the life of the person which is under the avalanche. And there is a similar scenario. This is a rendering because this project has just started. We are now, we just completed the first year of this project. So you won't see many actual experiments because we're still in a sort of feasibility study phase in which we are developing the ideas that we will implement on the actual scenarios. And this is a summer scenario. There's been a victim here, and also you will see an operator in a while which is wearing a sort of biokinetic sensor suite, and he is instructing motions, and also, as you will hear in the video, there will be some verbal commands, like the blue quadcopter has to lift up, has to land, or has to do some operation. So you can also combine the human-robot interaction techniques, not only visually in a sort of virtual environment, but also verbally in terms of the voice interaction. So this was a short or long video lecture on aerial manipulation. I hope you got an interest towards this research field, and I wish to take this opportunity to thank the International Journal of Advanced Robotic Systems for having invited me to give this lecture. So happy 10th anniversary. And as you can probably recognize, the picture is taken in a soccer stadium. I am shooting this lecture during the World Cup, the Soccer World Cup, because robotics is my passion, but life is priorities. And soccer is a slightly higher passion than robotics. Thank you.